Great, are we ready to start? Okay, welcome everybody. This session is about audio programming in C#. It's a topic that I'm very interested in. It's a real privilege to be able to speak about it today. Just to quickly introduce myself. My name's Mark Heath. I'm a Pluralsight author. I've created over 20 courses on Pluralsight. 3 of them are about audio. Nobody watches those, but most of the other ones are about Azure and microservices and that kind of thing. Because my day job is working with Azure, building software for the police. And probably the most relevant thing for today's talk is that I'm the author of an open source library called NAudio, which attempts to enable you to do audio programming on the .NET framework. And so this talk is kind of a bit of a story, really, of how I came to create NAudio and some of the challenges that I faced along the way. So we'll talk a bit about some of the C# aspects of it. And I'm hoping I might even at the very end have a time for a very short demo. So let's dive in, because there's quite a lot to cover. And the story starts actually in the last millennium. How many of you are old enough that your career started in the last millennium? And back in the day, we would typically use a variety of languages. So I was doing C, C++ programming, but I was also using things like Python and Visual Basic. And the idea was that each language was good at different types of thing. And of course, C is a compiled language. That means you compile it into machine code, whereas some of these other languages are what's called interpreted languages. And that means that as you're running your program, your source code is being converted into machine code on the fly. And so the general understanding was that if you wanted fast, and often with audio programming, you want your code to run very fast, then you should be in the world of C and C++. Also, if you wanted to go low level, if you wanted to call Windows APIs, or if you wanted to communicate with devices, you would want to be in the world of C. But of course, the downside of C and C++ was it gives you many ways to shoot yourself in the foot. And so often we would do as much as we could in the interpreted languages, because they did nice things like abstract the operating system away and allow us to do what we called RAD, Rapid Application Development. But it was about this time that I stumbled across Java, sort of the very end of the 90s. And Java was interesting because it didn't fit very neatly into either of these two worlds. Java, basically, you compile into bytecode, which how many people here are .NET developers? So you'll be familiar with intermediate language. It's a similar, basically the same concept, really. And you compile your code into bytecode, and then a virtual machine, in this case the Java virtual machine and the Java runtime environments, will run that by making use of the just-in-time compiler. So it's actually compiling your code as it runs, but it's doing it in a more efficient way than typically the interpreted ones will do, because once you've compiled part of your code, you don't need to recompile it to run it again. It also came with a slightly different approach to garbage collection, or to memory management, using the garbage collector. And that's going to be very relevant to us later on. And so I started using Java. And in my mind, it was kind of still in the slow category. You wouldn't dream of doing audio programming in Java. And then I came across this project called Java Layer. And what Java Layer is a fully written in Java decoder for MP3 files. Of course, this was the late 90s, so all of us were ripping our CD collections to MP3s and playing them on Winamp. And so MP3 was all the rage. And what really impressed me with this project was not only could it decode MP3s to PCM, but it included a player. So it could play them in real time, and Java had got the wrappers in a package called javax.audio that could write to the sound card. And so this kind of blew my mind. I was not expecting Java to be able to do this. And actually, this project is one of the first ones I converted to .NET. And it's available on GitHub. If you want a fully managed MP3 decoder, I've rewritten it. Well, it's been rewritten 3 times since I initially did it. But it's available at NLayer on GitHub. And of course, not much later, .NET came out. And the thing I liked about .NET was it was a much more Windows-friendly development environment than Java. Java was very much more in the Linux world, and when you built an application, it didn't even look like a Windows application. So I was very interested in .NET, and it came with multiple languages. It came with you could program in VB.NET, which was similar to VB, but all the VB6 programmers hated it. You could program it actually in Java, in Visual J#. Did anyone use that? I'm probably the only person. I actually converted that Java layer to .NET using Visual J#, but Microsoft kind of got in legal trouble and that died. There was also managed C++, where you could write .NET applications in C++, and in theory get the best of both worlds, but I found it felt more like the worst of both worlds. I found it confusing to use. But of course, C# has become the flagship language of .NET. And when .NET first came out, you could download it, but you could also fill in a form for Microsoft to post you the .NET beta on CD. And because I didn't have a very fast modem, I opted to be posted the .NET beta. And the first thing I looked for was, where is the audio support? Where is the .NET equivalent to javax.audio? And to my disappointment, there was absolutely nothing. No audio support. And I thought maybe Microsoft would rectify that, but basically they have never really done it. Maybe not until 2016, actually. So I decided I'm going to start my own open source project. It's going to be called NAudio, and my goal is going to be to make wrappers, two goals really. One, to make wrappers for any audio capabilities in Windows. So anything that Windows can do with audio, I wanted you to be able to do it in .NET. And I also wanted to create building blocks, so common useful classes that if you're building an audio application in .NET, you'd be able to piece them together and make your application. So in my evenings, I got started, and I worked my way through some initial features like audio playback and recording. I got working. I gave it the ability to read and write some of the most common audio file formats, so the WAV file format, some of you will know about, and the MIDI file format, if any of you are musicians. I had read and write support for those. And I also really wanted, as I said, to be able to play MP3s, because that's what everybody's music collection was in. But a couple of years after that, I got a new job, started working for a company called NICE. I'm still there, almost 20 years later, so I think that says it is actually quite a nice place to work. But NICE were actually about to embark on creating a brand new application called NICE Inform, which was an incident reconstruction application for use in public safety. So for example, the police might have lots of recordings of 999 calls and recordings of police radio conversations, as well as things like dash cam videos. And they wanted to piece it all together on a timeline and to play it back, all in synchronization. And it occurred to me, this was the moment for NAudio. And so I volunteered, let me be the one to make the audio playback engine for this application. And although my vision for NAudio had always been about music, that was kind of my passion and my hobby. I love doing a bit of home studio recording, and I wanted NAudio to enable musicians to write code. Actually, a lot of the things I needed for this voice-based application were very similar to what you might need in a digital audio workstation. So I had to implement things like variable speed playback. There were some basic effects like automatic gain control, so if somebody's talking too quietly, you boost the level. I had to be able to cope with the fact that the audio I was playing wasn't fully downloaded, so it was downloading while you were playing, so you had to kind of automatically pause and resume. I had to deal with audio and video synchronization, which is absolutely horrible. I don't know if anybody has tried to sync just two video players. When you ask them to reposition, they don't go to where you ask them, they just go somewhere roughly close. And so you spend all your time then after repositioning trying to get them back to where they should be. audio actually is much easier to mix, because with audio, what you do is you don't, if you've got 3 things to play, you don't open 3 instances of the sound card. You basically mix it first, so you've got perfect sample synchronization, and then you send that audio to the sound card. And so NAudio has a 32-bit mixing engine. Those of you who've done audio programming will know that when you're mixing audio, you want to be using floating point numbers. So you convert your audio to IEEE floating point numbers, and then you can mix them together. It means you've got lots of headroom, you won't clip, and you can reduce the volume if you've gone over before sending it to the sound card. The sample rate was actually very low. If any of you are into music recording, you'll know that you normally operate at much higher sample rates. But for telephony and voice recording, you often use very low sample rates because it reduces the bandwidth, and human voice is perfectly intelligible at quite low sampling rates. And I also had to do a bit of audio visualization, drawing waveforms. I've open sourced all of that. You can find that on GitHub. I did it both for Windows Forms and for WPF, because they wanted to redact bits of audio if it was going to court. And perhaps one of the most interesting things that this application was used for was the investigation into the landing of the plane on the Hudson River. So they took all of the air traffic control recordings and the black box recordings, and they pieced it all together in this program and used the .NET Audio engine to work out what had happened and whether this pilot had done the right thing or not. I won't spoil the movie for anyone who's not watched it. Now, one thing to just rewind slightly that I realized when I offered to put my NAudio code into a commercial program was that in most of us, I don't know, has anyone actually read their contract of employment? So well done if you have. But somewhere in there, it probably says something like, any code that you write or you think about while you're working for us belongs entirely to us. And I realized that this could be a problem if I just stuck all of the NAudio code. And although NAudio, in my mind, was an open source application because I had a SourceForge page for it, and I couldn't work out how to use CVS at all. It completely confused me. But occasionally I uploaded zip files of builds I'd done. I realized it needed to be a bit more of a proper project. And fortunately, Microsoft had come out with Codeplex, now sadly dead, which was an open source hosting platform that Windows programmers could actually understand how to use, which was nice. And so I put NAudio onto Codeplex, and I gave it a license. Microsoft decided that none of the open source licenses were good enough, and they would make up their own. And so I gave it the Microsoft public license, which is a commercially friendly license. And so that meant it could be taken into a closed source commercial project. I've now moved to GitHub and MIT licensing for it. So that, let me just check how we're doing for time. That's a bit of a story about how the NAudio project came to be. By the way, going on to Codeplex was one of the best things that happened because it started to give the project more visibility, and I got some really cool contributions. I'll hopefully have a chance to mention a couple of them. But let's shift gears a bit now and start talking about what it's like to do audio programming in C# and on .NET, and what are some of the challenges. And the first thing that I had to do tons and tons of was platform invoke. So basically reading C++ header files for all of the Windows APIs and working out how to call them in .NET. Have any of you done any pinvoke? Okay, well done. It can be quite painful. But for those of you who've never done it before, what you do is you basically tell .NET there is a native implementation of this function. So this example is wave in, get dev caps. So I'm asking, what are the capabilities of this recording device? And I use the extern keyword to say it's in an external library. The DLL import attribute is saying that it's in the WinMM DLL. And then for all of the parameters and return types, you have to basically work out what is the equivalent .NET type that matches this. And so often in C, they're using multiple layers of hash defines. So you have to say, well, what is a W param or an L param or a D word? And eventually you work out how many bytes it is, and you put ints for 4-byte integers. One of the mistakes I made early on is that I was quite lazy with interchanging int pointer with int, because everything was 32-bit back then. Of course, when 64-bit Windows became a thing, everything broke, and I had to make sure I was using int pointer correctly everywhere. But often you have structures. So C programmers love their structures, and so you have to create your own equivalent structure. So here we've got a wave in caps structure. And what you can do, you can actually use structs or classes in C#. They'll both work. But you have to lay out your structure exactly as the C structure is laid out. And in fact, this attribute, which is struct layout sequential, is telling .NET, you can't mess with how you store this in memory. It has to be exactly like this, because native code is going to be reading out of it and possibly even writing into it. So it's got to be laid out exactly right. Also, if there's any C, C++ programmers around here, you'll know that there's many ways of dealing with strings. And so whenever you've got a string, there's often an extra attribute you have to fill in to say, this is how this string is going to be passed around. Is it a pointer to a string? Is it a wide string? Is it just a block of bytes that the string is allowed to be in and might not even have a null terminator? That kind of thing. So I did tons and tons of that. The next big challenge is garbage collection. And on the whole, I've only got good things to say about garbage collection in .NET. It just works. It's really fast. It uses a very clever algorithm called a generational mark and sweep algorithm. But it introduces two big problems for audio programming. And the first problem is the way that the garbage collector works in .NET is that every now and then, not under your control, it will decide to stop your application. And by stop, I mean all of your threads stop, so none of your code is running. Then it will look at all of the memory that's been allocated, and it will decide if any of it can be freed. It will free it, and then it's also allowed to move stuff around, so it can compact things. And as I say, it's very efficient and fast. It doesn't always do a full collection. Sometimes it does like a partial collection to make it quick. But the problem is, if you want to do low latency audio, this can be a real pain. And by low latency, what I mean is, imagine I've got my MIDI keyboard here, and I want to press a note. I want to immediately hear a sound. I don't want to push down the note, and then half a second later I hear a sound. That would make it almost impossible to play. And the way that low latency is achieved, basically you give small buffers of audio to the sound card very regularly. So maybe 10 milliseconds, sometimes it's smaller than that. But you might give the sound cards, here's 10 milliseconds of audio to play, and while it's playing it, you make the next 10 millisecond buffer. And if you ever miss giving it a buffer, you'll hear popping or crackling sounds in the audio, and you certainly don't want that in live performance. So the fact that the garbage collector might get in and steal some of your 10 milliseconds is a really big deal if you want to achieve low latency. Of course, not every application does need low latency. There's some applications where it's not a big deal to have, let's say, half a second of latency. So it's not always a problem. The other problem is the compaction. If I've given some native code a pointer to a memory address, and then the garbage collector moves it, you're going to get a very nasty crash. So what are the solutions to these problems? The solution to the pause is you can't really stop the garbage collector from working, but what you can do is do your best to write allocation-free code. So if you're using buffers in particular, pre-allocate your buffers. Don't create a new buffer every time, but have a few buffers that you've pre-allocated, you fill them, and then you reuse them as the sound card gives it back to you. Of course, if you've got a user interface on your application, it's kind of tough luck. WinForms, WPF, they're allocating memory all the time. So there will be garbage collections happening. In terms of the compaction, there's two ways that you can do it. One is you can pin, managed objects, you can tell the garbage collector, you're not allowed to move this object, and it won't move it. Or you can just decide, do you know what, I'm not even going to ask .NET to give me this memory, I'm going to ask the operating system. So you can use native memory. So just to quickly show you a couple of techniques that you can use for pinning things first. C# has actually got two very rarely used keywords, the unsafe and fixed keywords. Unsafe does a very good job of scaring most programmers away from using it. But if you use an unsafe keyword, you can have a fixed block where you actually get a pointer to a byte array, and then it will not move in memory, but you can also do casting, which is very useful, and hopefully we'll talk about again shortly. But the fixed block isn't always suitable. Sometimes you need something to be pinned for even longer, and so you can use the GC handle class to allocate a pinned handle, and that basically tells the garbage collector, you're not allowed to move this until I free it later. If you want to use native memory, then the Marshall class in .NET is really useful. It's got lots of helpful methods. You can basically allocate some memory from the operating system and just get a pointer to it. And then you can use methods like structure to pointer, and there's also pointer to structure, where you can copy from a C# structure into a native pointer and vice versa. And so that is another way of getting pointers to things that are not going to move. Of course, if you do that, you must remember to free memory, just like if you're a C or C++ programmer. Otherwise, you'll get memory leaks in your application. OK, another interesting question that came up several times in NAudio was whether I should try to port code from other languages to C#, or whether I should just write interop. And that particularly is the case when you're thinking about digital signal processing, maybe some complicated algorithms like fast Fourier transforms, but also especially with codecs, so MP3 encoding and decoding, AAC, all of these different codecs. There's often absolutely tons of code and complexity involved in implementing the codecs. So I certainly wasn't going to do it myself. And the choice is whether, as I say, whether you do interop to a DLL that's got it, something like libfaac or even ffmpeg or something like that, or whether you try and get all of the code into C#. One of the advantages of the interop approach is it's typically a lot less work. The amount of code you have to write is way less. Theoretically, maybe it runs faster. I'm not sure this is necessarily true anymore, but at least the DLL that you've been given has been optimized to a high degree, and so you've only got the marshalling overhead of actually calling into it. It's much, much easier to keep up to date. So if you take the trouble to port a code base to C#, and then the next week they do, surprise, there's a new version, having to port all of the changes is a real pain in the neck. And it also helps you just avoid porting bugs. I've spent far more time than I wished I had in my career porting code between different languages. And you often find very subtle bugs can get in, particularly with things like bit shifting, bit manipulation. The syntax can be exactly the same between two languages, but the implementation can be different, like what happens to the sign bit as you move things across. So it's nice to just avoid that. But of course, the big downside is it can't run everywhere. It can only run on the platforms that support that you've got a binary for. And so the big advantage of porting an algorithm is that you've got fully managed code that is portable. It can run on any operating system. Back in the early days, I used Silverlight a lot. I thought Silverlight was great. And I could use the bits of NAudio that didn't use pinvoke in Silverlight. Also, I've found a number of people using NAudio using Unity, which I've never built anything in, but they're targeting iOS and Android. And so they can't use anything that I've just done wrappers for Windows APIs. So again, having things native is really useful. And just as an example, I needed resampling in NAudio for a number of problems where you're converting audio from one sample rate to another. And at first I thought, oh, I could just do my own algorithm. Turned out to be a mistake. You actually need to know a bit about digital signal processing to do it well. So I started making wrappers. Windows has got several APIs that let you wrap, that let you do resampling, the audio compression manager, DirectX managed objects, media foundation transforms. So I did all of those because different SKUs of Windows, like Windows Server, will have one but not the other, and Windows, I don't support Windows XP anymore, but I supported many versions of Windows over the years. But then I started to think, well, maybe I can port somebody else's algorithm. And the big trouble that you run into is licensing. Almost all of the good audio code out there on the internet is GPL or LGPL, which is not compatible with the NAudio license. But eventually, I found a resampler by a company called Cocos, who make the Reaper digital audio workstation, which is the one I use. And I got in touch with them, and they were OK with me porting it. So I had a fully managed resampler in the end. OK, let's talk about Windows audio APIs. I kind of feel like I know way more than I wish I did about all the Windows audio APIs. But Microsoft have many APIs for audio. The first one is WinMM. And WinMM has been in Windows since the very early days. It was in there since 1991. And if you've seen any of the APIs that begin with wave in, wave out, there's some MIDI ones, there's mixer ones. They've all been in there for ages. They're all still supported. You can still use them. They work absolutely fine. They are unfortunately high latency so you're not going to be able to do live music performances with them. You can't really get below 50 milliseconds at the lowest with them. But those were the first ones I did. And actually, probably the wrappers I've made for those are still the widest used. I did run into a number of problems that it gives you a choice of callback methods. So when the sound card tells you that it's finished playing a buffer of audio, you can choose for it to directly call a function, which sounded a great idea, but I realized that you've got to be super careful what you do in that function or you'll get a deadlock. And you can get posted a Windows message, which was much more reliable, but then it forced everyone to take a dependency on WinForms, which not everyone liked. But you can also use mutexes, so you can wait on a mutex, and that's actually the best way, the way that I recommend people use NAudio. But then in 2007, Microsoft decided to break everything and reinvent everything with Windows Vista, and there was a complete refresh of the audio stack. So I think WZAPI is the Windows Audio Subsystem API. And it's a massive, sprawling API. It's got hundreds of things in it. I still haven't finished writing wrappers for all of it. It's also a COM-based API, which brings some interesting headaches of its own, particularly about threading. If you create an object on one thread and then try and use it on another thread, depending on what type of object it is, it will not work. But it had the concept of exclusive mode or shared mode. So when I'm playing audio, I can say, I either want to share the sound card with other programs, or I want exclusive access. And if I've got exclusive access, then I can have much lower latency latency It also basically, when it initially came out, you had to give it audio as floating point samples, and you had to give it audio at whatever the sample rate the sound card happened to be at. So if somebody had just watched a DVD, you had to give it 48 kilohertz audio, and if they'd just played a CD, you had to give it 44.1. And that was really annoying because it had no resampler. It does have a resampler now, but that's why I needed a resampler for NAudio to cope with this. It's also got some other nice features like loopback capture, so you can record the audio that's being played by your system while it's being played. And so WZAPI actually is probably now the way I recommend that you use NAudio, but it's only recently really that it's become a better choice for most people than WinMM. Then in 2016, Microsoft decided to make yet another audio API. And this was for the Universal Windows platform. It's called AudioGraph. And what's cool about this one is it's already all .NET objects. So you can directly, without having to do a wrapper layer, you can use AudioGraph in .NET. And I was quite excited about this. I made a Pluralsight course about it that I thought was really good, but absolutely nobody watched it. And it's got a graph-based API. And I actually think that's the best way to design an API for audio programming, the concept of a graph where you're connecting things together. I would say it's the best. It had potential to replace NAudio because many of the things NAudio can do, AudioGraph can do. It has one fatal limitation, and that is you cannot make a node that transforms audio, that does an effect. The only way you can do an effect is you have to make a COM object, separate project, implement a COM object, and then load that into your other program, which is just a pain in the neck. So I really hope they fix that at some point, but I'm not using it because of that limitation. The final one I want to mention is not a Microsoft one, and that's ASIO. Anybody familiar with that? Maybe if you do music recording, you will know that anyone who is doing live music or music recording will not use any of the Windows APIs because they're all unreliable and dodgy. And this interface created by Steinberg in '97 is the best for absolute super low latency. If you want to get the minimal latency and you've bought a nice sound card, ASIO is great for that. And one of the cool things about being an open source project is every now and then someone will contribute something that's really good. And somebody contributed a wrapper for ASIO into NAudio, which I think is brilliant. It's a little bit different the way it works in that record and playback are together in ASIO. So they're not treated as separate devices. And that's actually good if you're recording because you want to synchronize. You want to know that this, while I was listening to the backing track and I played this on my guitar, it lines up exactly here. So ASIO works really well for that. OK, so I talked about, when I mentioned the AudioGraph, that is, I think, a good way of doing an audio API. But what is the fundamental way that we should design audio APIs? And I've already hinted at this, that with audio, we're often connecting things together into signal chains. We've got a guitar that produces some sound, we plug it into one effect, we plug that into another, and we go to our amplifier. And in audio programming, it can actually be more complicated than that. We might have multiple things that are producing sound. So I might have a microphone, and I might also have a pre-recorded file. I might put an effect on the microphone, so actually transforming the sound as it passes through, like reverb. Or I might not be transforming it, I might be doing visualization. So I might want to draw a volume meter or a waveform. But then we want to mix our audio together. And then you might actually send it to multiple outputs. So you might send it to a sound card, and you might also write it to a file, or you might send it over the network, stream it or something. And so NAudio tries to enable you to do this. And we won't have time to go into all of the API of NAudio, but probably the two most important interfaces to understand the audio graph are the iWave provider and the iSample provider. Now, iWave provider is basically saying, I can give you audio data. And so I need two things if you can give me audio data. I need to know what format your audio is in. Is it mono or stereo? What sample rate is it? Are you using integer bit samples? Are you using floating point? Maybe you're still compressed. Maybe it's like an AAC file. So that's what the wave format property is for. But then the read method is just saying, I want to read a number of bytes of audio out of the stream into my buffer. And I'm sure if you're .NET programmers, you'll have used streams. And this is exactly how streams work, a file stream, a network stream. Any stream has a read method that lets you read into a buffer. So it's essentially taking the same idea. However, if you've done any audio programming, you'll know you don't really want byte arrays. You want to get at the samples. And Samples can be, they can be 16-bit, they can be 24 bits sometimes. But really, if you want to do digital signal processing or mixing, you want floating point samples. And so iSample Provider is exactly the same thing, but you're getting floating point samples. And so that makes it much easier for you to work on them. So my recommendation with NAudio is to get to Sample Provider as fast as you can, and then do all of your processing that you need to do. And NAudio tries to help you with this. There's a number of classes that kind of try and get you pretty much straight there. Now, one of the troubles of going from a byte array to a float array is that casting, and this is very difficult in C#. So if I have a byte array that's got some audio in it, and actually I know that really in that byte array are floating point numbers, you cannot just cast it to a float array. That will not compile. And so I was looking for a solution for this for NAudio, because I wanted to cast, because that's fast, but .NET's not going to let me do it. So one of the options is to use that unsafe and fixed keyword. So that is how I initially did it. It does work, but it puts off a lot of programmers. A lot of people don't feel confident doing that in their code and understanding how to do it. So I was also looking for other ways. You can copy things around. So you can say, OK, I've got a byte array, and I'm going to move everything over into a float array. Of course, that's a performance problem. You don't really want to do that. And then came another genius, slightly mad genius contribution to NAudio, which was what's called the wave buffer. And the wave buffer basically uses a trick in .NET that is designed for when you're using unions, where you're doing interop to unions in C++. Is anyone familiar with what a union is? So in C++, it's very common in your structure to say, at this memory address, there might be one of these, or there might be one of those, or there might be something else. And the way that you represent that in .NET is you say that I've got an explicit structure, and that I'm going to tell you the exact address or the exact offset in the structure of every member. And what you can do is, therefore, you can put several things at the same offset. So you can tell .NET that at the same offset in my structure, same memory address, there's a byte array and a float array and a short array. And it turns out if you do this, you can write into the byte array and you can read out of the float array. And I was a bit scared. I did not believe this was going to work. It has worked flawlessly for 20 years. And basically, it gives me casting. There's one weird quirk that if you try and ask the float array how long you are, it'll be confused about how long it is. So, but apart from that, it works. And so NAudio is based on this little trick that saves us copying memory or having to always go to fixed blocks. However, if only there was something called span. If only this had existed a long time ago. Have any of you used span of T? This is, I can't remember when it came in. It was in fairly early in .NET Core, but 3.1, yeah. And this is perfect. This is what we've needed forever. Basically, I could change my wave provider and sample provider to just say, read into a span of byte. And what a span is, basically, it's saying, I don't care whether the actual memory backing this is managed memory from .NET or native memory from the operating system. I just want to be able to read in and out of it like it's an array. It's also got length built in, which is really convenient, and you can slice them, so you don't have to pass around all of those length and offset parameters that you have to with streams. And it supports casting, which is absolutely brilliant. So I can be given a span of bytes, and I can say, actually, I know that this has got floating point numbers in it. So you can, using the memory marshal.cast, you can cast it. So that's brilliant. I actually created, in the NAudio GitHub repository, there is a branch where I've converted NAudio to span. I did it a number of years back, and I kind of put it out there to the community, what do you think? And the VB.NET people said, oh, we can't use span, which surprised me. I kind of imagined that you could do everything in VB.NET that you could in C#. But it kind of ended up getting parked a little bit. It would be quite a big breaking change. But if I were ever to kind of do a NAudio version 3, I think span would make much more sense. And in fact, .NET has made many strides forward since the early days when I started on .NET Framework. We now have .NET Core, which is now just .NET. I love the fact that there's so much focus on performance. It is much faster, and therefore it's becoming a much better platform for audio programming. And also the fact that it's cross-platform. So you can use NAudio on Linux, just don't try and call Windows APIs because they're not there. There's also much better support for things like function pointers. You've got control over the actual intermediate language that you emit, which is really useful if you're doing some COM interop and the IL that it emits isn't quite what you want. And we're also starting to see a lot of code generation approaches to platform invoke. So there's a new library import attribute that replaces DLL import and will code gen the marshalling code for you. And there's a library that Microsoft are maintaining of interop wrappers, although in some ways I kind of prefer my hand-rolled interop wrappers because you can choose the types that are make most sense for your use case. So sometimes the code gen ones aren't actually very helpful. So can you use, let me just check how we're doing for time. I think we're okay. Can you use .NET for audio? Absolutely, yes you can. I've shown you my NAudio project, which I've used to build a lot of things, but I also have had contact with lots of other people who built all kinds of stuff. I've got a fully managed MP3 decoder. I've built, one of the things I made was a Skype voice changer that would intercept the audio in Skype calls and change your voice, put silly effects on. Sadly, it doesn't work anymore, but that is open source. I made a MIDI file mapping tool that if you've got drum beats that are designed for one sampler, it converts them over to another sampler. I've actually built several commercial products for voice and telephony recording using .NET. But maybe the slightly sad ending to this talk is the fact that I started NAudio over 2002. How many years ago is that? Over 20 years ago. And it was a fun hobby project. I was enjoying it. I was doing it for fun. But you know, life circumstances change, and I think a number of open source projects in the .NET community are going through this situation where maybe their original maintainers haven't got the time to work on them anymore. And certainly I found that although I'm still doing audio programming, I'm not typically doing it in .NET as much as I was. I'm doing it in other languages, DSLs for audio programming or JavaScript and so on. And so I haven't actually had the need to work on NAudio as much. So I would say that NAudio is no longer under active development. I do fix bugs, I do accept PRs, I do answer questions almost every day, but I'm not really working a lot on adding new features to it. And so it is open to new maintainers, so if that's something that does interest you, I'd be very happy to have a chat. But I think we have time for a very short demo. So let me unplug this. And okay. So let me just check what you can see. Can you see Visual Studio? Don't worry about not being able to see the code. Basically, this program, what it does is first of all, it's asking what audio devices have I got, and I'm actually using this Roland Groovebox as a sound card. And so I'm going to pick that. And then it's also going to ask what MIDI devices have I got. And I've got this little mini MIDI keyboard, so it's going to listen to MIDI messages that are being sent from this MIDI device. And what it will do is that when I press a key on here, it will receive a MIDI message. It will then use a synthesizer entirely written in C# to synthesize a sound based on a file format called a sound font. The synthesizer isn't my work. It's somebody else's project called Melty Synth that integrates really nicely with NAudio. And so if I press the key on here, hopefully, we will hear some sounds. If I press these drum pads, they're sending messages on channel 10, which in MIDI convention means they're going to be drum sounds rather than note sounds. And I can even play MIDI files. So if I press a key here, oh yeah, you're seeing, hopefully you're seeing, it's reporting the MIDI messages that it's receiving as we're getting them. If I press the spacebar, it will actually load a MIDI file, and it will play the MIDI file through the C# sequencer. So let's start that up. Make sure it's not too loud. Okay. So that is my talk on audio programming in .NET. It's something I'm quite passionate about, so I'll be very glad to chat with any of you further. But did anyone want to ask any questions? I don't know how much time we've got left. Yep. Let me just.
Hi. So, Blazor's like a big thing now. WebAssembly.
Yep.
And browser, there's the web audio.
Yep.
How well do you think NAudio's sort of API would map onto that? And could you make a sort of fork it into a Blazor browser version?
You could. So you could take, obviously none of the p-invoke stuff would make any sense. But you could take the, the classes in NAudio that deal with file formats and deal with resampling and various codecs that are fully managed, and you could call them. The only thing I say is, like, what exactly would be the point? Because actually, the browser audio is really quite good. You can find a lot of, I've been playing a lot with the web audio. Things like Tone.js do what NAudio can do and a lot more. With WASM, if any of you have used VST plugins and synthesizers, you can actually compile those to WASM and load them in the browser. And there's some amazing demos of that. And so I think audio in the browser is really going places. But I don't really see that NAudio contributes an awful lot unless you love C# and you want to be always in the world of C#. But I can recommend the Audio Developers Conference. You can get an online ticket for that fairly cheaply. It's happening later this year. And lots of really exciting stuff happening in the audio space in WASM. Yep. And how about .NET MAUI? OK, so I haven't done a lot of MAUI, but Carl Franklin, who's here, and I think he's talking about MAUI, has tried to do some audio stuff in MAUI. And he got in touch with me, and he was like, oh, can we kind of use NAudio with MAUI? And what you find often in these APIs is that the audio playback support is play this file. And if you want to produce your own samples and give it to it, that isn't good enough. And when I looked into it not too long ago, MAUI did not let you just give it samples. You had to give it a file stream. And so, unfortunately, again, you could use bits of NAudio in MAUI, but you can't do the really fun stuff like I just showed there. You couldn't do that because it doesn't give you the ability to inject your own samples directly to the sound card. Yeah, I mean, NAudio has got interfaces. It's got an iWave player, and it's got an iWave in. So you can implement those for other platforms. I think some people have actually done that, but they're not part of NAudio itself. But on MAUI, I don't even know how you would do it, because it's just not... OK, yeah, that's a good idea. Yeah. Yeah, so you kind of make a shim for NAudio to send audio out through the Web Audio API. Yeah, that's a good idea. Great. Any other questions? If not, thank you very much.